All right, this is Honors Algebra 2 Pre-Calculus. We're doing 5.8 in Algebra 2. This is our first video, solving quadratic inequalities. So in this series of videos, we're going to learn how to solve these in 3 ways. We're going to learn by hand using a sign chart, which is a particularly useful skill in calculus moving forward. We're going to learn how to do it by hand using a graph, but not really like a calculator level graph, just a graph based on our previous knowledge. And then we're going to learn how to do it on a calculator in general. But both methods where we solve by hand involve factoring, which is a super duper important skill, right? So awesome. We're also going to learn how to graph quadratic inequalities in 2 variables. So let's move forward. So some important facts. So a dichotomy in the world is something where there are 2 clear-cut answers, right? So for instance, in binary, there's 0 and 1, right? All of computer stuff that you're built on is the fact that you use is built on the fact that 0 is not the same as 1. So there's a significant trichotomy, meaning 3 distinct non-overlapping possibilities in math. Every number is positive, negative, or 0. Every single number, real and imaginary. There's no such thing as a positive or negative 0. It's just 0. It's in its own category. So every number, whether it has an I or it doesn't have an I, whether it's a square root of 2, it doesn't, like, every number can be categorized as either positive, negative, or 0, only one of those 3 things. So a lot of what we're going to do with these inequalities is built on that information. So if we only care about whether a product is positive, negative, or 0, then we really only care about the signs of the individual factors. So what we can do is make what we call a sign chart to determine when a product is positive, negative, or 0. For instance, we know negative times negative is a positive, and if we extend this a little bit farther, like logically, if we extend the concept farther, if you have an even number of negatives, then the thing comes out positive. If you have an odd number of negatives, which is what you're seeing in both of these cases, if you have an odd number of negative numbers, then the product would come out negative, right? And if either of the factors are 0, the product is 0. So sign charts are a hugely important skill that's going to come up repeatedly in calc and other college level courses. To solve quadratic and higher order polynomials inequalities, we need to make one side equal to 0, factor, and then we're going to go ahead and figure out how to make a sign chart from there. So let's walk through this. So we're going to solve and give our answer in parenthetical notation. You only have to solve one way, but I'm going to show multiple options so that you see choices. Okay, so one side is already 0. Great. So the first thing I should do is I should recognize what question's being asked. This is asking when this function, right? So when this function is positive or 0, right? That's what greater than or equal to 0 means, positive or 0. So that's what's being asked here. Is I'm asked for what values is this thing, this x squared minus 6x minus 7, positive or 0, right? So here's what we're going to do. We're going to pretend it's an equation. We're going to pretend it's an equation, and we're going to factor x squared minus 6x minus 7 equals 0. Well, that's going to factor into an x minus 7 and an x plus 1. And you can double check that by foiling, and you absolutely should. But you're going to end up getting that either x minus 7 is 0, which gives you x is 7, or x plus 1 is 0, which gives you x is negative 1. So these, right, these are my 2 zeros. So using these zeros, I now have 2 options, okay? So those are my 2 zeros. If I'm doing this by hand, I have 2 options. So this, I'm going to do this information for both option 1, which is a regular old sign chart, right? And option 2, which is sort of a visual sign chart. I'm going to have to do that for both of them. Sign chart, I can spell. All right. So if I want to pick option 1, so here's what option 1 is going to look like. When we make a sign chart, what we do is we put the x values that we got in ascending order across the top. So negative 1 and 7, those are my 2 zeros. And the reason I have these extra lines here is that this graph actually goes forever. It starts at negative infinity, goes to infinity. And then what I'm going to do, so across the top, I listed the roots or the zeros, right? Then I'm going to list the factors. So my factors were x minus 7 and x plus 1. Well, the trick with x minus 7, I can either fill in my sign chart. So I know x minus 7 is 0 at 7. I know x plus 1 is 0 at negative 1. I can fill out my sign chart in one of 2 ways. There's nothing after infinity. I can either plug in a number between negative infinity and negative 1. That's fine. If you chose to do that, you'd probably pick like negative 2, right? Just as an easy number. You'd get negative 2 minus 7, which is a negative, and you'd get negative 2 plus 1, which is a negative, right? A number between negative 1 and 7 might be 0, right? I could pick 0. That would give me a negative 7 and a positive 1. And a number between 7 and infinity, I'd probably pick 10, right? And that would give me 10 minus 7, which is positive, and 10 plus 1, which is positive. So what that means is that my product, right, my x squared minus 6x minus 7 is a negative times a negative, which is a positive, a negative times a positive, which is a negative, and a positive times a positive, which is a positive, and it's 0 here and here. So since I was asked, remember that I was asked where this thing is positive or 0. Well, my answer would then be from negative infinity to negative 1 with a bracket because it had that equal to for 0, and then again from 7 to infinity. Now that's fine, okay? That's option 1, and that's great. There is a faster way to figure out this positive and negative thing. If you think about what this factor behaves as, x minus 7 is a line with a positive slope, meaning that if it's 0 at 7, it's physically below the x-axis before 7, hence these negative signs, and then it's physically above the x-axis after 7, hence this positive. You could do the same thing with this x plus 1. It is also a line with a positive slope, so it's negative before it hits that 0, and then positive anytime after that 0. So that's a faster way to fill it out without plugging in numbers. So I get this answer, and that's great, okay? The second option is if you use what we call a visual sign chart. So option 2 plays on a different kind of knowledge. Option 2 plays on the fact that you know that x squared minus 6x minus 7 is a smile, right? Because it's got a positive in front of that x squared. Well, if you know that the zeros are at negative 1 and 7 in numerical order, right, and it's a smile, then it has to look like this. So if you want the windows where this function is physically positive, that's going to be where it's above the axis. So you get the same answer. See how, again, you get negative infinity to negative 1, include negative 1 because 0 is included, 7 to infinity. Same answer, right? So the third way to do this, right, the third way to do this is if you have a calculator, you can physically figure out where this is true, right? I'm going to point out that you really don't want to be banking on your calculator for these if you don't have to, right? So if you were going to do this in a calculator, right, I have x to the second minus 6x minus 7, right? And I'm going to zoom 6. So you can see visually in the calculator, you could second calc 0. So that's the third option, right? That doesn't require you doing anything by hand. But realistically, just being honest, it's not going to be a great option. So if I did this, I could do second calc and I could pick 0, right? And I'm going to scroll to the left of this 0 and hit enter, and then go to the right and hit enter. And there's my first one, right? And so I can see physically this graph is positive or before negative 1, right? And then it's 0 at negative 1. And then I could do the same process again with second calc 0. And I could scroll over till I get to what I know is going to be a 7 because I've already done the math, right? I scroll over to what I know is going to be a 7. Left bound, cross the axis, right bound, and then hit enter, and there's my 7, and again I can see that I get the same answer, that this graph is physically positive or 0 from negative infinity to negative 1, and then again from 7 to infinity. All right, so again, I don't care how you solve that, but that's the goal, is to be able to solve that. All right, cool, moving on. So you're going to try a P1 the same way. Again, I don't care what method you use. I'm a big fan of either the sign chart or the visual sign chart. I don't think that you should be relying on the calculator as your primary method of solution. So notice that this is saying when this function is negative, right? That's what less than 0 means. It's saying when this function is negative. So that's what I'm being asked to find, is when is this function negative. So I'm going to pretend it's an equation. Oh, I want to actually add a side note about this. So here's why you can't just do this. So I'm going to write something that's not okay. Here's why you can't just factor this and then say that each factor is less than 0. Okay? It is not that x plus 3 is less than 0 and x plus 4 is less than 0, because what would happen if you did that is you'd be saying this is a negative times this other thing that's a negative. A negative times a negative is not negative. That's not how math works. So this is not right. Okay, so you can't do this. You have to find the zeros and then either use logic or a sign chart to figure out when this thing is equal to 0, or is positive or negative, rather, sorry. So I factor this, and again, if you're factoring it in your head, nobody thinks you're cheating, right? If you were able to just look at this and spot that these are the two zeros, nobody thinks you're cheating. So these are my roots, okay? There are two ways to do this. Option 1, right, is to make my sign chart that starts at -infinity to -4, which is the lower number, to -3 to infinity, and list my factors. X plus 3 is 0 here. X plus 4 is 0 here. And so the product, which was x squared plus 7x plus 12, I can figure out when this thing is positive, negative, or 0 using my sign chart. Remember, there's nothing after the infinity. So again, you can either plug in, like let's say you pick -5, and let's pick, now here's not fun because you have to pick negative like 3.5, and here you pick 0. It's hard to pick numbers to plug in sometimes, so the better option is to recognize that this thing is a line with a positive slope. So it will be physically negative until it crosses this 0 and then become positive. And that you can confirm that by plugging in the -5. -5 plus 3 gives you a negative. Negative 3.5 plus 3 gives you a negative, and 0 plus 3 gives you a positive, right? Same thing's true here. X plus 4 is also a line with a positive slope, meaning it is negative before it crosses the axis and then positive after. So it's going to look like this. And you can confirm that by plugging in those numbers. -5 plus 4 is a negative. Negative 3.5 plus 4 is a positive, and 0 plus 4 is a positive. So negative times a negative gives me a positive. Negative times a positive gives me a negative, and then positive times positive is a positive. Since we want when this thing is negative, my answer is going to be just from -4 to 3 with parentheses because it didn't say equal to 0, right? This is my answer. The other way to do this, if you weren't going to do this on a calculator, and again, I'm not going to suggest that you do, is you still find those zeros at -4 and -3, but you recognize that x squared plus 7x plus 12 is a smile, right, because of the x squared having a positive in front of it, right? That's what makes this thing a smile, is that this is a positive number. So it looks like this. So if you want when this thing is physically negative, your answer is that same window from -4 to -3. All right, moving on. All right, so we're going to solve, and we're going to give our answer in parenthetical notation. Again, I don't care how you solve. I'm going to walk through at least one way, if not two. Okay, so what this is saying is that this entire function is positive, right? That's what greater than 0 means. So that's what you're being asked. You're being asked, when is this function positive? So when I factor this, the first thing I'm going to do, so I'm going to make it an equation, right? Because I know I need to find when it equals 0, and then I can make my sign chart one way or another. I'm going to take out a -1 GCF. You don't have to do that, but what I'm going to point out is if you don't do it, it makes your life significantly more difficult. Most of the time in all the factoring that we've learned to do, we learn to do factoring by having this leading coefficient be positive. So I'm going to end up with factors that are a 2x and an x. I want a +5, so I don't want the 3 opposite the 2 because they have the same sign. So what's going to happen is I'm going to get that either -1 is 0, which is a lie because -1 is always negative, or 2x plus 3 is 0, which is x equals -3/2, or x plus 1 is 0, which is x equals -1. So when I make my sign chart, -infinity, -1.5, -1, and infinity, right? So my factors are, don't forget the -1. That's a factor. 2x plus 3 and x plus 1. All right, so again, I don't care if you're plugging in numbers or if you get my logic about the line. I really don't. There's nothing after infinity. So, so this is my -2x squared minus 5x minus 3. All right, so -1 is literally always a negative. It's not just a negative, it's a -1 all the time, forever and always. So both of these are lines with positive slopes. You can plug a number in if you want, but I think it's easier to recognize that 2x plus 3 is 0 here. It is negative before it crosses that axis and positive after. The same thing's true here. This is negative before it crosses the axis and positive after. So negative times negative times negative would net negative, right? An odd number of negatives comes out negative. Negative times negative comes out positive, and negative, positive, positive comes out negative, right? With these spots being zeros. Since the question was, when is this thing positive? My answer is only here. So my answer is going to be negative 3/2 to negative 1 with parentheses, not brackets, because it didn't say equal to. Now, you can also see that if you had done this, right? So if you look at this answer, remember negative 2x squared minus 5x minus 3, this negative 2 means that this thing's a frown. So if you were to draw the frown, again, I'm terrible at drawing, but you get the gist. There's your frown. This is when this graph is positive. And it confirms the same interval that we just figured out. All right. Now, there's always somebody who says, okay, what if I didn't factor out the negative? So let's say you didn't factor out the negative, and that's fine. But if you didn't, you're going to get one of two options, okay? You're either going to get negative 2x minus 3 times an x plus 1. Let me double check that that pans out. It does. Or you're going to get the 2x plus 3 and a negative x minus 1. I don't care which of those you get, but what I want to point out is if you did the sign chart thing, let's just say, let's pick this one for argument's sake, okay? Let's say you did a sign chart with this. You're going to get the same answer, but your sign chart isn't going to have the negative 1 on it. Your sign chart's going to have this negative 2x minus 3, right? If you did this, you still get the same everything else, okay? But here's what happens. So I'm just going to go ahead and write product here because I'm lazy, okay? So the product of those two things, this guy is now aligned with a negative slope. So what makes that different is now that there's a negative slope, it's going to start out positive, hit 0, and then cross below. So now it looks like this. And this guy still has a regular positive slope, so he's going to be negative before he hits 0 and crosses after. You'll notice I get the same exact answers. So there's a lot of different ways to figure this out, but I'm still getting that same window. So if you didn't take out the negative 1, I would say that that's not a great plan, but it's not wrong and it still works, okay? All right, moving on. So P2, same way. You can pause me if you want. So first thing I want to note is that this is asking me when the function is 0 or positive, right? Because that's what greater than or equal to 0 means, right? So that's what you want. You want to note, hey, that's what you're asking me, right? That's the question. When is the function 0 or positive? Once you know that, right, then I'm going to pretend it's an equation, right? Now, if you can do this in your head, if you can just find the zeros in your head, nobody thinks that's cheating, right? But you do need to be able to find the zeros. So I have a 3x and an x. I want a 10, so I'm pretty sure the minus 3 has to be opposite the 3x to give me a negative 9 and a negative 1. So I get x is 1/3 and x is 3. So again, I don't care which of these options you pick. If you're one of these folks that says, hey, wait a second, this thing's a smile, and I know where the two zeros are. They are at 1/3 and 3. Notice it is important that you put them in numerical order, right, ascending numerical order. So it seems to me that if you want when this thing is positive or 0, it's here and here. So if you were able to just look at that and say, cool, my answer is negative infinity to 1/3 with a bracket, and then again from 3 to infinity, that's awesome. If you're somebody who wants to make the other kind of sign chart, and what I will say is as the curves get more complicated, you're going to want to know how to make this more detailed sign chart. For a quadratic or even a cubic, I'll be honest, I frequently just do this. But as the curves start to get really complicated, you're probably going to want to be able to make sign charts the way that I'm doing it here. Again, you don't have to necessarily, but it's going to get harder and harder to see when something is positive or negative. Both of these are lines with positive slopes, right? Because the 3 is positive and the 1 is positive. So 3x minus 1 is 0 here, so negative before it crosses that 0 and positive after. Again, if you like it better plugging in numbers, you could just pick 0 to plug in here and 1 here and like, I don't care, 10 here, and you'll get the same values. For x minus 3, it's 0 at 3, negative before it hits 0, positive after. So I get positive, negative, positive, and sure enough, and the zeros on those lines, that confirms the same answer I got the other way, okay? All right, so for example 3, this is a little bit trickier because we are not looking at something that is currently equal to 0, right? So what we have to be mindful about when we do this problem is that negative 12 is not the same kind of number as 0, right? 0 is special. It's part of that trichotomy where numbers are either positive, negative, or 0. So very first thing I have to do is add that negative 12 over. So I'm going to add that 12 over, and now I can look at what the question is actually asking me. It's asking me if this function, right, is negative or 0, right? That's the question I'm being asked. So now I can do everything the same way I've been doing it, but I can't start until I move that 12 over. So I'm going to get x minus 6, x minus 2 equals 0, which gives me x equals 6 and x equals 2. So then beyond that, it's up to you which sign chart option you pick. If you see that this thing is a smile and you want to say that your roots are at 2 and 6, And so it's like this, and you want when we are negative or 0, which is going to be here. That's fine. Your answer is going to be a 2 to a 6 with brackets because it said or equal to 0. If you want to make a sign chart, the other kind of sign chart, right, you can put your factors here. You're starting at negative infinity. The next 0 is 2. The next 0 is 6, and then up to infinity. X minus 6 is negative until it crosses the axis and then positive after because it's a line with a positive slope. The same thing is going to be true with x minus 2, but it's 0 at 2. And so then my result, right, my x squared minus 8x plus 12 is positive, negative, positive with zeros on these two lines. And sure enough, that gives me the same information. All right. So when you go to try P2 or P3 rather, you're welcome to pause me. It's the same idea. I have to move that x first. So x squared minus x minus 2 is greater than 0. So now I can look at what I'm being asked. What I'm being asked is when this function is positive. That's the question that I have to answer. So I need to look at it as an equation and see when these values are 0, right? Now, certainly you could also use the quadratic formula to do this. We haven't been because it's easier to factor in most cases, but if something didn't factor, then you would have to use the quadratic formula to find the roots. So once I get these here, again, which way I choose to do this is entirely up to you. If you want to look at the fact that this is a smile because it's got a positive in front of the x squared, then you could definitely put your roots at -1 and 2 and draw the smile. Since you want when this thing is positive, your answer is going to be negative infinity to -1 with a parenthesis and from 2 to infinity. And that's great. If you'd rather do the other kind of sign chart, which again I recommend as math gets more difficult, so if I want to do my other kind of sign chart, my factors were x minus 2 and x plus 1. You'll notice that both of those have positive slopes, right? Both of those are lines with positive slopes. So if you find where those values are 0, they are both negative before they cross their 0 and then positive afterwards. So I get positive, negative, and then positive with zeros on these lines. And sure enough, that's those two windows right there. Same answer. All right. So there's a couple different ways to do this one, interestingly enough. Okay. So you can either, so some of you are probably going to say, oh, well, I would FOIL this out, right? This is x squared minus 2x plus 1 minus 4. Which is an x squared minus 2x minus 3, which is an x minus 3, x plus 1, right? That's fine, okay? But there's actually another interesting way to factor this if you want. You could notice that this is a difference of squares. This is a squared minus b squared. So you could actually factor this as a plus b, right? And a minus b, and sure enough, you're going to get that that's an x plus 1 times an x minus 3, which is the same factored form, right? Different order, it doesn't matter. Okay, so either way you choose to do this, you're getting that this function, right? So you want when this entire function is negative or 0, right? So you can find quickly that your two zeros, if you treat this as an equation, right? Your two zeros are when x plus 1 is 0 or when x minus 3 is 0. So that's at -1 and 3. And then you can make your sign chart either like this and recognize that this thing is a smile. So it's going to look like this, right? And you want negative or 0, which is going to be here, right? So that means that your answer is going to be -1 to 3, right? That was a 3, not a -3, my bad. So that's fine. Or you could do this with a sign chart that we've seen a couple times now, where I start at negative infinity, -1, 3, and infinity. And then my factors were, doesn't matter which one you do first, x plus 1 and x minus 3. We've seen what happens if you have a line with a positive slope. It's negative until it crosses at 0 and positive after. And the same thing here, negative until it hits 0, positive after. And there's never a problem with just plugging in numerical values for each of these windows if that's easier. So positive, negative, positive, and these lines were both zeros. That's my answer. All right, last one. Same idea, right? You could do this in one of two different ways. You could either spot that this is a difference of squares, which is great, or if you don't spot that it's a difference of squares, then you could FOIL this out, right? So there's two different ways to take this 3 minus x quantity squared minus 25, right? There's two different things you could do. You could either FOIL this out, in which case you're going to get an x squared minus a 6x plus a 9 minus a 25, which is going to be x squared minus 6x minus, sometimes my brain is tragic, 16, right? And so then you're going to get x minus an 8 and x plus a 2. That's fine. The other way you could do this is to recognize that this is a difference of squares, where your a is 3 minus x and your b is a 5, right? So you'd get a plus b times a minus b. And if you did that, you'd get a negative x plus 8 and a negative x minus 2. Now you'll notice that these are actually the same two things, but your sign charts are going to look a little bit different. These are the same because if you were to factor a negative out of both of these, you'd get the same two factors. So it doesn't matter to me which way you do it. I'm going to pick this one just because it's different. Okay, so I'll use this because it's a change. It's a little bit different, right? Either you could also use the other one. It's fine. So if I wanted to find the zeros, right, so this is asking me for when this function is negative or 0, right? That's what I'm being asked, right? So you want to know what you're being asked because then you know what to answer, right? So if I go ahead and find where these things are 0, right, it's going to be when negative x plus 8 is 0, which is going to be at x equals 8. And it's going to be at x, negative x minus 2 is 0, which is going to be at x equals negative 2, right? So those are my two zeros. And again, it doesn't matter which of these options you pick, right? So this is what the thing FOILs out to. So it's a smile, right? So you can either pick this option where you say, cool, here's negative 2, here's 8. It's a smile when I FOIL it out, right? And since I want when it's negative or 0, this is going to be my winner. It's going to be negative 2 to 8. That's fine, okay? That's one way to get it. The other way to do it, and I wanted to make a sign chart with these negatives just to show you what happens, right? If I do this with these negatives, here's a negative infinity, my negative 2, my 8, and my infinity, right? So both of these are lines that have negative slopes, right? So this is a line that has a negative slope and this line that has a negative slope. So it's going to be positive before it crosses the axis. See how it's positive and then it crosses and becomes negative. And then this one is going to be the exact same situation. It's going to be positive before it crosses the axis and the negative. And you'll see that my product, right, so the product, I'm just going to write product because I'm low in space, is going to be positive, negative, positive. So this is my winner, right? So the window is the same. Again, either of those are fine ways to do it. It does not matter to me which one you pick. I just wanted to show you that you have different options. And our next one is our next video.